In this video, we'll be looking into NECO 2025 Chemistry Practical Preparatory. So this is the titration aspect, also known as volumetric analysis. So these are the specimens we'll be needing for the titration part. So what I'll be doing now is that I want to work out how you can derive your volume of acid use, like using calculation method without even doing the practical at all. So please just follow the procedure I want to take now. It will guide you at least to have an idea of how to get your volume of acid use. That is your VA. So without even performing the experiment. So from what NECO sent to school as an instruction, I mean the specimen. So we have all this. Now look at this. Firstly, this is Na2CO3. It is a basic salt. You get it now. So since a basic salt, well, it's now going to be a weak base. So I don't want to go to the explanation deeper. So Na2CO3 is representing or is acting as a weak base. So we also have NaNO3 as well. So what will happen in these two compounds is that you see these two, this NaNO3 will not react with HNO3. So it is only the Na2CO3 that will react with what? With HNO3. So this NaNO3 will only serve as what? As an impurity, because from the instruction, you'll be told, we'll be told to mix these two compounds together. This guy NaNO3 will not react with this. It is only this guy that will react with this. So this one will only act as an impurity into the what? Into this mixture of these two compounds. So now what am I saying is, what am I saying in essence is that from the NECO question, like the possible things NECO will ask you is that they will ask you to calculate maybe the percentage purity of this guy, or maybe the percentage impure of this guy. So there will be something that will deal with impurity or purity, you get. So that kind of question will be in what NECO will set for you, because of they have added this NNO3 to the what? To the specimen, meaning that there will be an impurity in the base. So now let's go to the main business. So the formula you will use whenever you want to calculate the average volume of acid use, or the volume of acid use for this titration without even doing the experiment, is this formula. The formula is CAVA all over what? CBVB is equals to NA over what? NB. I'm very sure many students are familiar with this formula. So make your VA the subject of formula. That will be what? VA equals to CBVB NA all over what? CA then what? NB. So this is the formula you are going to use. Now, how are you going to go about the formula? How will you get all these parameters? Now let's start. That is where the work is, but it's very simple. And sure to watch this video to the end, because you are going to learn a lot from this video. So now, for me to get my NaNB, then I will need to write the equation of the reaction, right? So that will be HNO3 plus what? HNO3 plus what? Plus Na2CO3. So to give what? NaNO3 plus H2O plus what? Liberation of gas, CO2. You can put the state of matter, you may not put it. So balancing this reaction, if 2 is here, okay, so my N also have 2 here like this. Okay, so what again? Then my hydrogen is 2 here, my nitrogen is 2 here, sodium is 2 here, oxygen, carbon is 1 okay, balance, and oxygen is 6 plus 3, that's 9. Then 6 plus 3 F is balanced. Yes, it's balanced. So as you can see now, my Na mole of acid is what? That's from here, that's 2. Then my NB is what? 1. So I've gotten that. Now the next thing for me to get is to get my CB. Okay, we already know that VB, volume of the base, is usually 25.00 cm cube. At least we know that means the volume of your pipette. You understand? Okay, so some schools might use 20, but basically most schools used to use 25.00 cm cube. What again? So for my C, okay, So well, now what am I left with? I've gotten this, I've gotten this. So I've gotten this, meaning my CB and my CA. Yes, my CB and my what? And my CA. That's the next thing for me to use. Now for my CB, let me get my CB first. For my CB, that means concentration of B in mole per dm cube, and that will be equals to concentration of B in gram per dm cube all over what? The molar mass of B. Molar mass of B. So the molar mass of B now, remember that B is Na2CO3. So molar mass will be 23 times 2 plus what? Carbon is 12 plus 16 times 3. So let me press that into this calculator. So I will have it as 23 times 2. Okay, that will be 46 plus 12 plus 16 times 3. 16 times 3, that's 48. So adding everything together plus 46. So that will be 106 gram per mole. 106 gram per what? Per mole. So I've gotten the molar mass. Now for me to now get the concentration of B in what? In mole per dm cube. So that will now be CB will now be concentration of B in gram per dm cube is from here. Now look at this. This is the concentration of B in gram per dm cube. That is 5.5 gram per dm cube. As you can see it here. So then I will come here and write my 5.5 gram per dm cube all over 106 gram per mole. So if gram cancel gram, and then the inverse of this, so if I should divide this, then that will give me 5.5 divided by 106, and that will give me 0.0519 0.0519 mole per dm cube. Mole per dm cube. So I've gotten my CB. Now the next thing for me to do is to get my CA. Now that is the next thing for me to do, to get my CA. Now for me to get that CA, so that one will be, so for me to get the CA, I'll firstly get the concentration of A in mole per dm cube of the concentrated acid. You understand? I'll firstly get the CA for the concentrated acid first before I now get the dilute acid. You know that student can never use the conc acid. They rather use it in the word diluted form. So how would I do that? Then there's a particular formula we used to use, and that is this is the concentration of the acid, like concentration of A in mole per dm cube of the conc acid. Let me put it here, of the conc acid. Okay, so now how do we go about that? So how do we go about that? Then that is going to be 10 multiplied by specific gravity. So multiply by percentage purity of the acid all over the molar mass of the acid. Molar mass of the acid. So therefore, that's the formula you will use to get the concentration of A in mole per dm cube of the concentrated acid. Okay, so now what is the specific gravity? Specific gravity and percentage purity, they are always written as on the bottle, yeah, that contains the acid. So teachers we easily know this when doing dilution. So so we check the labeling, the paper on that bottle, you are going to see all this value there. So specific gravity of HNO3, specific gravity of HNO3 is a 1.42 gram per dm cube. So that is 1.42. And then what about for percentage purity? Percentage purity is always 70. So it's always 70. So after having this one, they are written in the on the label of the acid. So now let's now go to the formula. Okay, before that, let's calculate the molar mass. The molar mass of the acid. So that is HNO3. So, and then that will be H is what? 1 plus N is what? Nitrogen is 14. Yeah, nitrogen is 14. So then oxygen is now what? 16 times 3. So pressing this in your calculator, let me check. That will be 16 times 3 plus 14 plus 1. That is 63. So we have it as 63 gram per mole. 63 gram what? Gram per mole. Okay. So now let me now insert everything to this formula. So the Ca of the conc acid is now 10 times specific gravity is 1.42, percentage purity is 70 all over what? 63. So then that will give what? Let me press the calculator here. That will be 10 times 1.42 times 70. So that will be 994 over 63. So and that will give us 15.78. That is 15.78 mole per dm cube. Mole per dm cube of the concentrated acid. So now let us now find the concentration, like the concentration of the acid in mole per dm cube of the diluted acid. Now this is the value, I mean this is the concentration Ca of the conc acid. Now let us now look for it in the diluted form. Now what is it going to be? So therefore that will be, you are going to use a dilution factor formula, and that is C1 V1 equals to C2 V2. A lot of teachers will know this formula. This C1 means initial concentration, V1 initial volume, C2 final concentration, V2 final volume. So our initial, when you want to dilute something in the lab, our initial concentration is what? 15.78, as you can see it here, 15.78. So multiply by our initial volume. Our initial volume is given to us here. Now look at it here. Initial volume is given to us here. The volume of HNO3 is what? 6.30 cm cube. Okay. So now let's do it here. That will now be 6.30 cm cube. So is equals to our concentration is what we are looking for now. That is the C2, the final concentration. So let me write it as C2 times the volume. The volume, you see, now see they said from here, they said per dm cube. Meaning per dm cube means that's what? 1 dm cube. You understand? But instead of me to write one here, instead of me to write 1 dm cube here, I will not do that. I'm going to write it as cm cube. 1000 cm cube is what I'm going to write here, because this 6.30 is in cm cube. So I will need to write this one too in also in cm cube, so that the unit will be the same. So here will now be 1000 cm cube. At it being I converted this 6.30 cm cube to dm cube now. So that means here I will just write 1, because 1000 cm cube equivalent to what? 1 dm cube. So what do I do next? Then I'll do the arithmetic. So my C2 will be equals to, so that will be 15.78 multiplied by 6.30 all over what? 1000. So my C2 will now be, let me press the calculator here. So times 6.30 divided by 1000. So my C2 will now be 0.0994. Is 0.0994 molarity, or you call it mole per dm cube. Anyone, molarity, or you call it what? Mole per dm cube. So this is the concentration of the acid in mole per dm cube of the, concentration of the diluted acid. Let me use that English like that. Concentration of the diluted acid in mole per dm cube. So that's it. So is this value I now need now. So this value now will be what I will insert inside this particular formula, inside this formula here. So now let's go with the inserting all these values I've extracted here. Then let me now insert them into this into this formula I have here. Okay. So now from here, now let me write the formula again. That will be VA is equal to what? CBVBNA over CANB. So CBVBNA all over what? Let me check here. All over CANB. All over CANB. All right. So then now let me insert them. VA. My CB is what? Sorry for turning this book here and there. Then my CB is what? 0.0519. 0.0519. 0.0519 multiplied by VB is 25 times my NA. Let me check here. My NA is the 2. Okay, my NA is 2. Everything all over my CA. My CA is 0.0994. 0.0994 multiplied by NB is 1, right? Can you see it there? The NB is 1. So now let me press this thing into this particular calculator. So that will give me 0.0519 multiplied by 25 times 2. So divided by 0.0994. Good. So that gives me 26.10. So my VA is now 26.10 cm cube. Good. Good. So now that's the answer. So that is how to calculate the volume of acid used without performing the titration. So it's very simple. I've done that. So now let me now at least come up with a table. Like, how can you now permutate a table for this particular answer? You already know that your VA is this, right? So now let me permutate a table for this. So permutating table for this now will now be, okay, let me rule the table. Sorry, I'm using a free hand here. Okay. So if I should write here as Burette reading. So then here I wrote my first theta. Here I wrote my second theta. And then here is my third theta. As you can see. So let me read this. So here will now be the final Burette reading. So the next one will be initial Burette reading. Then here will now be what? Volume of acid used. Okay, so you have to put your unit. All right, so you can either put the unit here. Let me use my blue pen to put the unit. You can put the unit here in cm cube. Put it here to cm cube. Put it here to cm cube. So ensure that the unit is there. If you like, you can put it here, and here. But sometimes I love putting it here, and here. So either you put it here or you put it here. So it's okay. We are good to go. Okay. So we have said it there that our VB is what? 25.00 cm cube according to the way we did it. Okay. So now the final Burette reading. Let me start my initial here as what is 0.00. in two decimal places. 0.00 here. I want to permutate this 26.10. Okay, so let me put my first here as 26.10. Okay, okay, let me put my, let me still, okay, let me start my initial here as 10.00. You get? I started it as what? 10.00, my initial. So let me now make this one to be 36.00. Okay. If I subtract this from this, what would I get? I'm going to get 26.10. If I take away this from this, I'll get 26.00. Okay, so what again? Now I can now make here as also 0.00 as well. So doing that, then I can give here okay, since I want to 26 here, 26 here, I want to balance it to be 26.10, right? Okay. So let me give here as 26.20.20. Okay, so here can now be 26.20 as well. Good. So this is perfect. This is what? Very perfect. And remember that the interval between them should be what? Plus or minus 0.2. And if you check around from here to here is what? Plus 0. Plus or minus 0.1 occur here. And from here to here is plus or minus 0.2. So it is perfect like this. So I can now calculate my average volume of what? Average volume of acid used. So that will be my first titer plus my second titer plus my third titer all over 3. And that will be 26.10 plus 26.00 plus 26.2 plus 26.20, everything over 3. So if I should do the arithmetic, and that will give me 26.10 plus 26.00 plus 26.20. So that gives me 78.30 all over 3. All over 3. And that gives me 26.10. So that is 26.10. Don't forget to put your units, centimeter cube. So we are done with the titration. That's all. That's all. And remember that the indicator we are going to use is what? Methyl orange. We are using the indicator methyl orange. Why? Why are we using methyl orange? It's because the suitable indicator for the titration between a strong acid, which is strong acid, and a weak base. Strong acid and weak base. The best indicator there that is a must that you must use is what? Methyl orange. So indicator methyl orange. So now after going through this, we got 26.10. Again, if you wish, you can just write a rough titer here. So you can start this thing first with rough titer, write rough titer there and put any value for the rough titer, because since the rough titer is not really required, you cannot add rough titer to your what? Average volume of acid use. Rough titer should not be there. So you can also try to like write rough titer if you wish to. So I will be stopping this video here. Then my next video now, which I'm going to be uploading soon, is going to be the likely questions that they can set for you. Do you understand? The likely questions that they can set for you. So that will be my next video now, together with the SWOT analysis. The SWOT analysis aspect too. So if you need it, just say you want the part B video, then I will send you the link of the video immediately. Please share this video, encourage me. If you share this video, give me a like thumb. Even if you wish, you can give me a super thanks and also join our membership platform. So thank you so much, and I'll really be very grateful. Bye.